Okay, let's go for the next variation. And this variation concerns an attribute. Originally, we had in the class friendship an attribute status, a string valued attribute, and the attribute was initialized with the init clause, initialized to hold the value pending, because friendships can be pending, accepted, or declined. And this is what we wanted to record in this string valued attribute. And this attribute status was manipulated by the operations accept f in the friendship class and decline f in the friendship class. These two operations are in the friendship class. And yeah, as you see here, self.status was manipulated to be, was assigned accepted by the accept operation, and self.status was assigned declined by the decline operation. What I'm doing now as sort of an alternative is I'm making this attribute, I'm turning this attribute into a derived attribute. We saw a derived attribute already. For example, let's point to the particular point. The attribute initials was a derived attribute. Initials was the first letter from the first name concatenated with the first letter from the last name. That was a derivation rule for this derived attribute initials. And we have now a similar situation here. We have a derived rule, an OCL expression, which is a bit more complicated than the expression before for the initials attribute. This derivation rule uses an operation for checking a general OCL operation for checking the state of the state machine. So there is we have seen this operation before. There is an operation, general OCL operation, OCL in state, and then you can specify here a state of the corresponding state machine. So please be aware of the fact that yeah, we have the class friendship, we have a state machine, and we have declared here, in particular, we have declared here the states pending, accepted, and declined. And with this operation OCL in state, you can check whether the each object is associated with a running state machine, and you can check which state the state machine currently sits in. And you do so with this operation OCL in state. And what I'm doing here, it's sort of very simple. If the state machine is currently in state pending, then I'm returning here the string pending. If it is accepted, then I'm returning the string accepted, and analogously for declined. And otherwise, I'm returning here the null value. So this here is a sort of a bit more complicated OCL expression, nested OCL, nested if expressions. And this is the derivation rule, and as this attribute is now defined with the derivation rule, there is no need to manipulate this attribute anymore in the respective operation here. So the accept f and the decline f, and these were the operations assignments that were going on inside the implementation. And there, as we have it now as a derived attribute, there is no need to declare it now or to manipulate here the attribute. We have done this in the derivation rule. So the implementation sort of becomes empty. Nothing is executed here, but have in mind there is the operation in any case, the operation accept f, decline f, in any case will do something. It will do something here in connection with a state machine, namely accept f will change the state from pending to accepted, and decline f will change the state from pending to declined. So although the implementation here looks as if nothing will happen, nothing explicitly will happen here in the accept f and the decline f, there is something implicitly happening, namely the change of the state machine. Or the operation calls, both operation calls change the state chart status. Okay, next two variations, sort of small variations in the original class diagram we have associated here. There is a composition relationship between profile and posting, and we have used here as a multiplicity the one multiplicity. So a posting object must be connected to exactly one poster object, and there is a sort of alternative for this. Instead of, so originally we have stated here the multiplicity 1, and one could also associate or specify here the multiplicity 0.1 for the composition. This would allow that posting objects can exist without being connected to a profile, which does not make so much sense in our context, and therefore the original multiplicity was well chosen and was okay, but just as an alternative one, for a composition in general, you can have here on the side of the whole composition apart whole relationships, and on the side of the whole you can have a 1 multiplicity or you can have a 0.1 multiplicity. That was one slight variation in the multiplicities. There's another slight variation in the role names. You can have implicit role names or you can have explicit role names. In the original model, in order to demonstrate the option that you can have implicit role names, in the original use file, the association interest had no explicit declaration here of role names. So the role names as seen here below, the role names simply were missing. They were left out, and you can do so. You get then as role names implicit role names where the class name is used as a role name and the starting capital letter is turned into a lowercase letter, assuming that the class names begin with a capital letter. So implicitly you have here exactly the role names as given below, profile and subject, with starting lowercase letter. Implicitly you have them here without having explicitly written them, but you can also write the role names explicitly down and say here role, profile, role, subject, or you could choose here different role names. A last thing is about the placement of the constraints. Constraints can be placed inside a class or outside a class. Original, we had a constraint for the commenting class. The constraint was, we have discussed this in detail, the commenting is only possible for friends, and so the invariant formally was called comment only by friend. This was a technical formulation, and we have explicitly formulated this constraint with a constraints keyword and then with the declaration of the context class, context commenting, invariant, blah, 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 invariant name. You can move this constraint into the class definition itself, that is indicated here. So originally, the association class commenting started over here, and the definition ends over here. And now I've taken up the keyword constraints into the class, and I do not have to explicitly write here the context, because the context is clear. Now I am already inside the commenting class, so I do not need to write this context here. I can directly write constraints, invariant, comment only by friend, and then the technical formulation is not different anymore. One variation concerning the use shell. Our original longer scenario where we have created Merkel, Putin, Trump, and May, and Merkel has done one posting and published one posting, and Putin has commented the posting. And in order for Putin, so in this line here, in the original script, in the original salt statements, what I did was I was using a shell variable p here, and I was assigning this p to the result of Merkel.publish and then this parameter here. And this p was used later on in the command where Putin comments this posting with a particular text here. So that's the definition of the p, that's the use of the p. An alternative way is to you can simply use this operation here as an operation which changes the system state, and you do not have to catch the result here on the use shell. So although this operation returns something on the use shell, you do not have to catch the result. You do not have to assign the result. So this is demonstrated here. Instead of assigning the result, you can simply write Merkel.publish blah blah blah. And then in order to later access the posting, at this position here, instead of the p, what is done here is that a query is used. So instead of the variable p, which is used here, I have formulated here a query, posting.allInstances, and then please select any p such that p.poster is equal to Merkel. At this point in the script, in the dynamic behavior, there is exactly one posting object for which this is true, and this query will exactly yield the only posting object that is available. And so the alternative for keeping track of particular objects with a variable is that you can formulate a query at the particular point on the shell. And as you see here, in total, the formulation on the query now, the formulation on the shell is now getting a little bit longer. And it does not look nice if you put it into one long line. And it is, there's a feature that you can distribute a command that goes over several logical lines. And there's a way on the use shell to realize this. So when you want to have a shell command over several lines, well, you can do so by this formulation on the use shell. You are starting with a backslash, and then a different prompt opens here. Then you enter your command, and the command can go over several lines. So at this point in time, you're having a line break. The return keyboard stroke is done, and you can enter here several lines. You can enter also several, say, long query. If you have a query that goes over several lines, you can enter it here. And to end the command that goes over several lines, you are using here a line where you only have the dot, the period, as the only character. So you start here with a backslash, and you end with a period, and in between you have a command that goes over several lines. That's something that you can do on the use shell.